Welcome to a session on the photoelectric effect and Einstein photoelectric equation. First, let us see the definition of the photoelectric effect. The ejection of electrons from a metallic surface when the light of suitable frequency is allowed to fall on the surface is called as photoelectric effect. Let me explain. Here, this is the incident radiation or incident light. You know, light have certain amount of frequency, right? When this light of certain frequency is incidenting on a metallic surface, electrons are getting ejected. This phenomenon is known as photoelectric effect. The emitted electrons are known as photoelectrons. The so-called emitted electrons are called as photoelectrons. And if these electrons are collected and passed through a wire, then it constitutes some current. That current is called as photocurrent. This effect was discovered by Hertz when ultraviolet light falls on zinc plate. This is the first discovery. This phenomenon was experimentally verified by the scientists. They discovered that alkali metals like lithium, sodium, potassium eject electrons when visible light falls on them. Let us see the experimental study. This is the experimental setup to study the photoelectric effect. In this arrangement, A and B are two photosensitive surfaces. This is plate A and this is plate B. Plate A is called as emitter and plate B is called as a collector. They are enclosed in a evacuated quartz tube. So this is a evacuated quartz tube. Plate A is connected to a negative terminal of the battery. This is connected to a negative terminal of the power supply. Whereas plate B is connected to the positive terminal of the supply through the ammeter. Why ammeter? Ammeter reads current. In the absence of any light, if there is no light is falling on this metal surface, then there is no deflection in the ammeter. But when a beam of radiation is allowed to incident on the plate A, here this is the incident light. When it is falling on this metallic plate A, this is a photosensitive metal, which means uh, when incident radiation of sufficient frequency is falls on this plate, metallic plate, it ejects the electrons. That is called as a photosensitive metal. A current starts to flow in the circuit, due to which ammeter shows some deflection, which means that when incident light is falling on this plate, it ejects the electron. This plate ejects the electron. This effect is called as photoelectric effect. Because this plate B is also called as collector, is connected to positive terminal of the battery, it attracts the negative electrons. So positive terminal attracts the negative electrons. From this collector, the electrons enter through this wire, they passes in this direction. When they pass it through ammeter, it will show some current. This current is called as a photo current. This is the experimental study. Let us discuss laws of photoelectric effect. There are some laws. The first law is photoelectric current is directly proportional to intensity of incident light. The second law is for the ejection of photoelectrons from the surface of a given material, certain minimum frequency of the incident light is required. If the frequency of the incident light is less than the minimum frequency, no electron can be emitted from the metal surface, however intense the incident light may be. This minimum value of frequency is known as threshold frequency, or the corresponding wavelength is known as threshold wavelength. Let me explain these two laws with an illustration. Here, what you are able to see, a blue light is falling on this metal foil. What is your observation? A electron is getting ejected, which means photoelectric effect takes place. Repeat the same phenomena, repeat the same process with the red light. So this is a red light or a red photon. So what is photon? Photon is the particle aspect of the light. When this red photon or red light is falling on the metal surface, what is your observation? There is no ejection of electron. Photoelectric effect is not takes place. Repeat the same experiment with more number of photons, which means high intensity of the red light. Might be previous case, intensity of the red light is not sufficient, so you thought that the electrons are not getting ejected, but increase the intensity of the red light, so one photon got increased to 3 photons, even though there is no ejection of the electrons. Repeat the same experiment with highest intensity. Here more number of photons are incidenting the metal foil, but still there is no photoelectric effect, which means there is no ejection of electrons. Repeat the same with the blue light. As you increase the intensity of the blue light, what is your observation? More number of electrons are ejected. So 3 photons are falling, correspondingly 3 electrons are getting ejected. Similarly, repeat the same experiment with still higher intensity of the blue light. What is your observation? Correspondingly, there is a increment in the ejection of more number of electrons. So go back to the first law. Photoelectric current is directly proportional to the intensity of incident light. So it is obvious, when you perform experiment with low intensity, one electron emitted. When you perform experiment with high intensity, then more number of electrons are ejected. So the number of electrons ejected is directly proportional to the intensity of the incident light. The second one also you can understand from the same demonstration. For the ejection of photoelectrons from the surface of a given material, certain minimum frequency of the incident light is required. So you observed that red light is not capable of emitting the electrons because its frequency is less than this minimum frequency to eject the electrons. Whereas blue light is able to or capable to emit the electrons because its frequency is more than this threshold frequency. So this particular value of the minimum amount of frequency to eject the electrons is called as threshold frequency. The law number 3 is the kinetic energy of the photoelectrons depends on the frequency of the incident radiation and not on the intensity. So what is your observation? Here, when the electrons got ejected, the ejected electrons travel with some velocity and the electron have some mass. It's traveling with some velocity. So half m mass into velocity square is called as what? Kinetic energy. So the ejected electron have some amount of kinetic energy. This kinetic energy depends upon the frequency of the incident radiation, but not on intensity. Here, what amount of kinetic energy by this electron? The same amount of kinetic energy having by this electron also. But the difference is, as more photons are falling, more intensity of the blue light is you are incidenting on the metal foil, then obviously more number of electrons are emitted, but their kinetic energy does not depend upon the intensity. Purely it depends upon the frequency. This is the law number 3. The photoelectric effect law number 4 is the phenomenon of photoelectric effect is different from thermionic emission because the rate at which the electrons are emitted from the photocathode is independent of the temperature. So This effect is independent of temperature. Even you perform it to 27 degrees centigrade or 45 degrees centigrade, the same effect it will takes place. So it is not thermionic emission. Thermionic emission is something which associated with heat. The law number 5 is the time lag between the incident radiation and the ejected photoelectron from the photosensitive surface is very small. Almost it is an instantaneous process. When light is incident on this metal foil, instantaneously the electrons got emitted. Almost the time is 10 to the power of minus 8 seconds. It's very small. The stopping potential is proportional to the frequency of the incident radiation, but it is independent of its intensity. Let us see the Einstein's photoelectric equation. Einstein successfully explains this photoelectric effect on the basis of Max Planck idea of quanta or photon. According to Max Planck, radiation consists of tiny particles which are called as photons and having the energy equal to h nu, where E is the energy of the photon and h is the Planck's constant and nu is the frequency of the radiation. Each metal has a minimum energy needed for an electron to be emitted. This is known as work function. Here you can see when photon is falling on this metal surface, it will give some amount of energy to the electron. This electron utilizes this particular energy from the photon in two ways. First of all, it will get out from the metal surface. So the minimum amount of energy required by a electron to get out from the metal surface is called as work function. The remaining energy, if this photon supplies large amount of energy, then maximum energy it utilizes to what? To get out from the metal surface, and the remaining energy will be converted into kinetic energy. So the energy of the photon h nu is sum of the work function plus kinetic energy. So the total energy supplied by the photon is utilized in two ways. One is to get out the electron from the metal surface. This is called as work function. And the rest of energy is converted into kinetic energy. By rearranging this equation, kinetic energy is equal to h nu minus W. You can write h nu as h nu minus W as h nu naught. So kinetic energy half mv square equals to h nu minus h nu naught. This is called as Einstein's photoelectric equation. Applications of the photoelectric effect. It is having numerous number of applications. Some of the examples are night vision device take advantage of the photoelectric effect. Image converters, image intensifiers, television camera tubes and image storage tubes also take advantage of the point by point emission of the photocathode by using the photoelectric effect application.